When we look at the universe, everything we see, stars, planets, galaxies, makes up less than 5% of all the matter and energy out there. The rest? It's mostly dark energy and a mysterious, invisible substance known as dark matter. But what exactly is dark matter, and how did it shape the universe as we know it? Let's break it down. Hi, and welcome to Stellar Studies, your window to the universe. Let's start the adventure. Chapter 1. What is dark matter? Dark matter makes up about 27% of the universe, far more than the 5% made of the regular stuff, like you, me, and the stars. It is a form of matter that does not emit, absorb, or reflect light. This means it's completely invisible to telescopes. That's why we call it dark, since dark matter doesn't emit, absorb, or reflect light. So how do we even know it's there? We know because of gravity. Dark matter has mass, and mass creates gravity. It pulls on things we can see, like stars and galaxies. In fact, without dark matter, galaxies would fly apart because there wouldn't be enough visible matter to hold them together. Think of it like wind. You can't see it, but you know it's there because you feel its effects. Chapter 2. The role of dark matter in the early universe. To understand dark matter's role, we need to go back to the very beginning, 13.8 billion years ago, to the Big Bang, when the universe first formed. It was a hot, dense soup of particles, expanding rapidly. But this early universe was chaotic. As it cooled, dark matter began to act. Unlike regular matter, dark matter interacts very weakly, meaning it doesn't collide or slow down like normal matter. This allowed it to form clumps early on, creating the first dark matter halos, dense regions of invisible matter held together by gravity. Chapter 3. How dark matter built the universe. These dark matter halos became the building blocks of the universe. Their gravity acted like gravitational wells, pulling in hydrogen and helium gas, the first elements in the universe. Over time, this gas cooled and condensed, forming the first stars. These stars then grouped together into galaxies, all guided by the gravitational pull of dark matter. Without dark matter, the gas would have spread out too evenly, and galaxies like the Milky Way would never have formed. Today, we see galaxies arranged in a vast cosmic web. The filaments of this web are made of dark matter, and they connect galaxy clusters like beads on a string. This web is the framework of the universe, deciding where galaxies form and how they grow. Chapter 4. Evidence for dark matter's role. One of the first clues about dark matter's role came from studying how galaxies rotate. Stars on the outer edges of galaxies move much faster than they should, based on the amount of visible matter. The only explanation, an unseen halo of dark matter surrounding the galaxy, is providing extra gravity. We also see dark matter at work through gravitational lensing. When light from distant galaxies passes near a large clump of dark matter, the light bends, like it's going around an invisible mountain, creating distorted or magnified images. This helps us map where dark matter is concentrated. Chapter 5. What if there were no dark matter? What if dark matter didn't exist? The universe, as we know it, would be unrecognizable. Without this hidden force, the early cosmos wouldn't have had the gravitational glue necessary to form galaxies, stars, or planets. Instead, matter would have scattered too thinly across space, never clumping together into the structures we see today. Take our Milky Way, for example. Its iconic spiral arms are held together by the gravity of dark matter. Without it, those arms would unravel, sending stars flying into the void. Over time, the universe would become a chaotic, structureless expanse, and without planets or stars, life as we know it wouldn't exist. Dark matter is the invisible architect of the cosmos, shaping not only its form, but its very possibility for life. Chapter 6. The ongoing mystery of dark matter. Dark matter, what is it actually made of? The truth is, we don't know for sure, but scientists have been hunting for answers, and there are some fascinating clues. Many scientists believe dark matter could be made of exotic particles that are nothing like the protons, neutrons, and electrons that make up the stuff we see. One leading candidate is something called a WIMP, or weakly interacting massive particle. These particles, if they exist, would barely interact with regular matter except through gravity. Another possibility is axions, tiny lightweight particles that might behave like waves and interact with electromagnetic fields. Scientists are using advanced experiments, from underground detectors to powerful particle colliders, to search for these elusive particles. Some researchers think dark matter might not be made of particles at all. They are exploring entirely new ideas, like modifications to our understanding of gravity or unseen dimensions of the universe. To uncover the truth, researchers are using powerful experiments, like particle colliders and ultra-sensitive detectors deep underground, to catch a glimpse of these mysterious particles. Every discovery brings us closer to understanding the invisible force that built our universe. Conclusion: dark matter is the silent architect of the universe. It shaped the galaxies, stars, and planets that make up everything we see. It's the reason we're here today. If you enjoyed this journey into the world of dark matter, hit the like button, share this video, and subscribe to Stellar Studies. Let's keep exploring the mysteries of the universe together.